Now let's try to make a moving average. Again, we are copying everything in, so we're going to make a simple moving average. Insert a new sheet called SMA, simple moving average. And we just got to put in here. This is our, now we want to predict it. We want to have a moving average, simple moving average 1, SMA, simple moving average 1, and a simple moving average 3. Let's have a look at these two. First of all, if you want a simple moving average 1, it's just moving average is just taking the average of our index. Index is 1, so basically what we're going to do is we're just going to take a copy of everything and say we're moving at 1. Simple moving average 3 is where we want 3 items here. So we're going to take this as the average of the 3 previous observations. So we're going to make a few in here, and we're just going to copy this one all the way down. So it's basically just the average of the 3 previous observations. So we have a moving average 1 and a simple moving average 3. So let's have a look at the residuals for moving average 1. Res SMA 1 and a residual for SMA 3. 1 is of course equal to what we see minus what we predict, and the same here. What we see, sorry, we have to start down here, equal to what we see minus what we predict. And we're going to copy everything all the way down, so we're just going to do it like this. And copy it all the way down. Here we do have the residuals. Now, let's have a look at the graphs. Insert line plot. Here we are. Let's make it a little bit bigger so we can see what's going on. We see that the blue line is our observation. The red line is just our observations delayed 1, and the green line is sort of a smoothing thing. It seems as if we just want to keep the green one moving average, because it's just giving us the trends. It's instead of just having a total delay of 1, which gives us a lot of errors. So we just go for the green, which is the moving average 3, the trend. There we are. This is the trend line. We see that moving up here. This should hopefully be less, give us less of errors. We see if you just look at the residual themselves, MA3 is giving us bigger than the 1. So let's have a look at the MAD for 1, and we're going for MAD for 2, MAD for 3, where we just simply take the absolute values equals ABS of this, and this is of course the ABS of this one, absolute values. We're going to copy them down and going to add them up down here. See what we got. 149 and 123. You see the absolute values are smaller on the moving average 3. Again, I'm going to reduce these, and we notice that there should be 44 observations, and we've removed 3, so the average of this one should be divided by 41. This should be divided by 43. This should be divided by, again, by 41. this should be divided by 43. So if we just take the sum of the changes, some are positive, some are negative, this is definitely better for moving average 1. But if we say that an error is an error, no matter if it's too much or too little, we see that it's better for moving average 3. We can have a look at the squared. Let's call it res1 squared and res3 squared. This is of course equal to the residual here squared, and this is equal to the residual here squared. Let's copy it all down and see what happens. We take the sum here and divide this by 43. And according to the formula I showed earlier, we on the previous slide, it should be -2, so it's divided by 41, and we want the square root of this. We rule 2 degrees of freedom. The square root of that one is 41, a few less here. And we're going to take the same thing here. We're going to take the sum of them, and we're going to divide this one time by 39. And we're going to take the square root of that too. That's 41 observations minus 2 is 39. So 3.7. Again, it seems as if there are fewer large errors. So let's just remove the residual 1 and say that we go for the 3. So this is it, and let's have a look at the residual plot. Insert a line, and there we are. This is what it looks like. It seems there's the variance seems okay. So it looks fine. Average and variance seems fairly straight. So moving average 3 is our chosen model here.